Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 11 on gravitation. Students, let us solve question number 11. The question is that an object of mass m is taken from the surface of Earth to a height h above the surface of the Earth that h is also given, h that is equal to r by 2, half the radius of the Earth. Surface of the Earth, find the change in potential energy. So this is the question, and we'll have the solution here. So basically this is Earth. The question is that this is Earth whose radius is r and mass is m, capital M. A small point mass, suppose here, is taken from the surface of the Earth to a point here, which is this height is equal to half the radius of the Earth. This is the radius of the Earth. Then in that situation, what is the change in potential energy? Because when it is here, the potential energy is something else, and it is here, the potential is something else. So the change will give me, the subtraction of this from that will give me the change in potential energy. So the change in potential energy is final potential energy minus initial potential energy. So when it is on the surface, so the change in potential energy is final potential energy minus initial. What is the final potential energy? Minus, because the potential energy formula is minus G m1 m2 over r. So in this case, minus G m1 m2 means those two masses involved. One is the mass of the Earth, another is the mass of the object, which is on the surface of the Earth and taken above, divided by r. What is that r? When the object is taken from surface to a height here, the r is basically measured from the center. So this is your r, taken to a height r by 2, but then this r is also there. So r plus h is the value, that is r plus r by 2, that is 3r by 2. Minus, or minus is there, and this formula is again minus of g mm over r. R is now r, because initially this is the position and final position is this one. This is the initial position and this is the final position. This negative and negative becomes positive, so this will become g mm over r minus 2 by 3 g mm over r. This 2 will go up and this minus will come to this side. Now I'll write that this as a g mm over r common and 1 minus 2 over 3. So from here it is 3 minus 2, 1 over 3. So it is g mm over 3r. This is the change in potential energy I'm getting. That also I write in terms of small g how much it is. So change in potential energy is 1/3 g mm over r. But in terms of small mg, what will the answer? Then we know that this small g is gm over r square. So therefore gm will be gr square. So in place of g capital M, I'll write gr square. So it is 1/3 gr square into m divided by r. So one r will cancel out. Is mgr divided by 3 This is the answer to this question. So it is find the gain in potential energy is to height equal to the. So this is the answer to this question. So if the object is taken to a height equal to this is the answer. I'll just give you one formula that in general formula is there, that is n divided by n plus 1 mgr. That formula will give you the answer immediately. If the object in this situation is taken to height equals to r by 2, and how far it is taken, this h, how many times the radius of the earth. Basically the height is how many times the radius. Now half r is equal to half times radius, so this is your n. If you consider this as your n and substitute here, this will get half divided by half plus 1 mgr. This is actually 3 by 2, so this is half and this is 3 by 2, so 2 will cancel, this is 1/3 mgr. So the same answer you're getting. Okay, if I say that the object is taken to a height equal to radius of the earth, that means n equals to 1, because it's 1 times the radius of the earth. So if you put 1 here, then this will be 1, this will be 1, so 1 by 2 mgr. This will give you instant result. Okay, thank you.